This logarithmic function lesson that we're going to do today starts on a whole new thing. You may not have heard of logarithms before, but they go directly with exponents that we've been talking about, because a logarithm is sort of a different way of writing an exponential equation. So if we have the exponential equation b to the y power equals x, we know that b would be a base and y is your exponent. So if we have this written in logarithmic form, okay, a logarithm is a way to ask the question, what exponent goes with the base b, if we know that this is the actual answer to the question. So we would say log base b of x equals y. And then what this really means is that this b, whatever this number is, to the y power equals what this number x is. And we're going to go through and we're going to do some examples and really talk about how this looks, what it means, and rewrite some things. So, for example, if I have 3 squared equals 9, 3 squared equals 9, that will be the same as writing log base what? What's a base in this expression? Base 3. Log base 3 of 9 equals 2. So here's what it looks like. Log base 3 of 9 equals 2. Please make sure to write that down. That part's not on your sheet, but make sure to write it down there so that you understand with numbers what this means. Yes. Yes, like a question that you, yeah, sort of like that. Because the question would be asked like this. Log base 3 of 9 equals what? And you would be asking yourself the question, 3 to what power equals 9? And then you'd say, okay, my answer is 2. And you'd get an answer like that. And that's how the simpler ones are going to work, is that it would be something with a nice whole number answer. We are going to look at those that don't give us whole number answers. But they all go with this idea of understanding what a logarithm is. I have had somebody go through at one point that really couldn't stand algebra one little bit, but then they started really loving this chapter on logarithms. Who knew? But they said that they just really, they get it, that it makes sense to them. So hopefully that'll be your experience as well, that they're not really horrible and difficult. They're just something different that you may not have seen before. Yes? Yes. Yes. Log base 3, notice that it's down here at the base, like base bottom, and we know that this is our base in this problem, so it's the same word. Log base 3 of 9. So the answer to the question, if you have a base of 3, what exponent will give you 9 when you put it as the exponent for 3? That's what the log function is asking you. Okay, so in our logarithmic form, log base 3 of 9 equals 2. So what you'll see on your page then is several that we want to practice just writing it in logarithmic form. Because before we can move on, you have to be really good at being able to write it in logarithmic form. So let's just take a minute. Start with the word log. Log for logarithm. Log, and then write the base, and then the number that goes next, and then what that number equals. So for example, what would the first one look like? Good. So what he said was right there, log base 5 of 125 equals 3. Because 5 to the 3rd power equals 125. It's just writing it in a new form. How about this one down here with the 2? This would be what? Good. Log base 2 of 16 equals 4. And as I said, the point to this is being able to be given a question that looks like this, log base 2 of 16, and then figuring out what exponent would go with the 2 to make 16. So that's what these are, that's what we're going for here. So this would be what? Good. Log base 1/2 of 1/32 equals 5. Because 1/2 times 1/2 times 1/2 times 1/2 times 1/2, you got 5 of them, would give you 1/32. And then this one, good. Didn't fool you by putting it on the other side. Log base 7 of 49 equals 2. So once again, it's a different notation for the same thing. So that's where we go with it. So what we have next is you've got some questions. We've got a question for us to think about. And we'll write down a process for those that need a process. Some of you are good with your head knowledge and will be able to figure this out, but I will have a thing to write down for those of you that need a process. But does anybody know what the answer to this question would be? Yes. 5, because 2 to the 5th power equals 32. For those that need a process, and we'll need this for something else, you can write it again, 2 to the x power equals 32, if you're thinking about what number this is. And then once you have it there and you're thinking about it, the other step that you could do is you could write this with the same base. 32 is 2 to the 5th power. And then you notice that x has to equal 5. Now, like I said, some of you, and really where you should be, is some of you are able to evaluate quickly, wait a minute, what number, 2 to what power, and being able to figure it out this way. But this process is going to help you when we do have to have something that doesn't quite, it's not quite as easy as that, or maybe we'll end up with a fraction answer. But here's how our answer ends up being with this. And what we're going to do now is we're going to look at the next set. And even as you're looking at the next set, you might be thinking, wow, that looks a little bit different than what we did a minute ago. So let's take a look here. If I'm looking at log base 8 of 32, you might be thinking, wait, there's not an answer that's a nice, quick, easy answer for that. I want to put this on a sheet of paper so let's take a look at here, so I can write on it easily. All right, so log base 8 of 32. So let's think about writing that in our logarithmic form. Let's go ahead and do that. So how would I write this if I want to write it with an x and I want to write it with an exponent? What would I do? How would I write this? 8 to the x power equals 32. Okay, now this may not be super obvious at first. As a matter of fact, I'm pretty sure it's not. So what I want to do, myself a little more space. What I want to do is you want to rewrite it so that you've got like bases. So for example, 32 can be written as what to what power? 2 to the 5th power. 8 can be rewritten. 8 can be rewritten as what? 2 to the what power? 2 to the 3rd power to the x power. But what do you do with power to a power? Multiply. Good. Multiply. Whoever said multiply first. So 2 to the 3x power equals 2 to the 5th. So what things are equal here? The bases are equal, and then that tells us that 3x equals how much? 5. So 3x equals 5, because we have the same bases. They have to give us the same answer. So that means x equals how much? 5/3. So the answer to this question is that the log base 8 of 32 is 5/3. And so we have a fraction to go along with this to make this whole thing work out. Okay? We can do that with other bases, especially if there's a common base to work with. Some of them don't need it. So you always want to look for a simple thing first. But if you're not seeing a simple thing, try a couple numbers. Like here, if I had 4, I would say, okay, well, let's see. What about 4 squared? That's 16. 4 to the 3rd power, that would be too much. So let's try this base and exponent technique. So how would we write this one? 4 to the x power equals 32. Do the same thing that we did before. So this 32 would turn into 2 to the 5th. This would be 2 to the power of 2 multiplied times x, 2 to the 5th, and then that equals, okay, good, x equals 5/2. So we have log base 4 of 32. Now, with these different bases, I know that a lot of you like to use the calculator, and it has its place. You could use the calculator to check if you wanted by taking 4 to the 5/2 power. You could even use the little caret on that and find out that it does give you 32 to check, but there's not a one-step process to change this base on the logarithm to a different base. We do have some techniques we can use, but the techniques honestly are more difficult than this. So we want to take the easiest way first. Sometimes a calculator doesn't make things easier, it just makes it different. So what about this one? Log base 5 of 125. It'd be 3. There's really not much to do with that one because 5 to the x power equals 125. There's not really anything to know except that 5 to the 3rd equals 125. You can try exponents if you want. You can try bases. 2s are good bases, 3s are good bases, 5s are good bases. It's kind of like you're taking it and doing that prime factoring, like we did the prime factoring in order to find values. If you prime factor this, you'll break down and you'll find out what that like base is pretty nicely. Now this one's pretty interesting, this log base 64. Don't like it? Well, let's see what we got here. We have 64 to the x power equals 1/32. Let's think a little bit. What's 1 over a number mean? It's 32 to what power? The negative first power. Let's do that. And this is 64 to the x power. Now we can break down your 64, and you can break down your 32 to having, let's break it down. 64 is 8 times 8. This is 2 times 4. 2, 2. How many 2's are we going to end up with here? 6 2's. So this is 1, 2, 3, 4, 5, 6. So this is 2 to the 6th power times x. This 32 also breaks down. 32 breaks down into 2 to the 5th, okay, but just for those that need to see it, 2 times 16, 4, 4, 2, 2, 2, 2. So 2 to the 5th. So this is 2 to the 5th times -1, right? So this is 2 to the -5th and 2 to the 6x. Now it's starting to look not so difficult, right? You can. So here we have 6x equals -5, because they're like exponents are the same. So x equals -5/6. So once again, if you want to, you can actually check that in your calculator just to make sure. You can run our calculator. So just for those of you that may not have known what I was talking about with check it in your calculator, I want to do 64 to the -5/6 power. And that gives us that, but I want to see it in its fraction form. 1/32, and so yes, -5/6 is our actual answer here. So you can use your calculator to check. It just may not be necessarily with the log button. There is a log button, but it's not used for that. So here we go, back to here. So we have that all filled in. Now, if there is no little base written in your logarithm, if it's not written in, it is implied that the base is 10. It's kind of like the hidden one. When it just says log of 1,000, they're implying that the base is 10. So even it's kind of like a square root where the little index is implied to be 2. If there's no base, then the base is implied to be 10. So you can just find out the answer to this one turns out to be 3. Okay, simply because 10 to the 3rd power is 1,000. So just keep in mind that there is an implied base, just like if there is no thing in the crook of the square root. So this is log base 10 if it's not showing anything. So what is this good for? If you've ever heard about earthquakes being anywhere, and they come up from time to time, they'll give a number, and the number is a number on the Richter scale. And the Richter scale measurements, they will talk about the intensity of the earthquake. And so those numbers that can be given are related to how many times stronger a certain earthquake is than another earthquake. So it's not like these numbers like a 3.2 and a 3.7 are actually that close. One of them may be many times more than the other. And we're going to take a look at this problem that I've got here in order to explain how this works. And I'll take it just a little bit at a time so you've got this. Okay, so the ratio of I1 to I2, the ratio of the intensities. Intensity is how strong it is. So if we have that ratio and you can figure out that number, that's going to tell us how many times stronger one earthquake was than the other earthquake. So a higher number on the Richter scale does mean stronger. So our first value I1, our M1, is going to come from 9.3, and our M2 is going to come from 8.7. Those are our Richter scale numbers. So even though that doesn't seem like a number is too far apart, what that tells us is that the log of I over I2 equals 0.6. Okay. What's my base that's hiding here? 10. My base is 10. So this tells me that 10 to the 0.6 power, 10 to the 0.6 power equals the ratio of the intensities. That's what this is. I've got it written down for you, but just so that you see what's happening. 10 to the 0.6 power is the ratio of the intensities. So if you were to put in your calculator 10 to the 0.6 power, 10 to the 0.6 power, we get 3.98. 3.98, that's how many times stronger this earthquake is than this earthquake. So it would shake about 4 times harder, okay? The buildings would shake about 4 times harder if these were our two actual numbers, and they actually were the numbers. Okay, off the coast of Sumatra, there was an earthquake that was a 9.3, and it shook about 4 times harder than the one that hit at the same time, same place, 8.7 magnitude quake. So what we can think about is when you get to like a 9, it's a huge amount shaking, and it's a lot more than what you would have it at 8. It would be like if there's one number difference, it's 10 to the first power, which would be 10 times stronger. So every number, every complete digit on a Richter scale is 10 times stronger. So let's look at the other problem that you have on your sheet. This is our last thing that we'll do for today. And April 26, 2016, a 5.1 magnitude earthquake hit Japan. On April 16th, a 7.8 earthquake hit off the coast of Ecuador. Some of you might remember some of the different things that were happening. There was a lot of earthquakes happening that year, so I pulled some right from the news. And so we want to find out how many times more intense the quake was that hit Ecuador. So how do I set this up? 7.8 minus 5.1. So we take 7.8 minus 5.1, and then what do you do with the 7.8 minus 5.1? So we subtract it, and what do we get when we get the answer? What do we do with it? Our answer is what? 7.8 minus 5.1. 2.7. What do we do with the 2.7? So sure. 10 our base, 10 to the 2.7 power. So when we do 10 to the 2.7 power, we get over 500 times stronger. 501.187 times stronger. So huge amount of difference as far as the intensity, how much shaking, how much potential for damage. So there are certain places that they put into effect certain construction techniques, especially if they're prone to earthquakes, because they know that they're going to have the more intense ones. They make certain things inside the building so that when the building shakes, it's not going to rattle apart completely under the conditions that it was built to withstand. However, then sometimes more intense earthquakes will hit. Sometimes a less intense earthquake with less shaking can cause a lot of damage if the buildings are not built anticipating an earthquake. Although there is not an earthquake-proof building, I mean, there could always be one that will be strong enough to damage everything, but the closer to a fault line it is, the closer to where there have been historical instances of earthquakes, they put more care into making sure that everything is set up exactly the way that it needs to be for safety. And that pretty much, question?